For the exercises in this lecture, I will be using an old 3 gigabyte here, 3 gigabyte, actual 3 gigabyte. I will be using 3 gigabyte Visual Machine here, but you can use flash drive, they're almost same. We will do the storage equation on them. At this point, we should consider attaching our media to write blocker before examining it. If you have write blocker, if you don't have write blocker, yeah, just plug your USB device to it. So it's also important to continue using your write blocker if you have been acquiring and creating forensics image of evidence and drivers, in order to not write data to the drives or modify the original evidence files. So I'm telling this for if you have a write blocker, but if you haven't write blocker, you can just continue and do whatever I did in this lecture. Repeat this, and you can actually, if you haven't write blocker, you can continue your practical examples. So it's not mandatory to have write blocker. So to list your devices and ensure that you are aware of them before performing any execution operations, the sudo fdisk l command is good to list your storage devices. Here, as you can see here, I have system storage device. There is a 79 oops. As you can see, there's this 79 gigabyte Linux, 1 gigabyte extended, and 1 gigabyte swap partition I have in my 80 gigabyte storage device here. And as you can see, I have 3 gigabyte storage device as well here, FAT32, and this label type DOS, this identifier here, this is the hex byte. And we have sector sizes, we have units, and we have disk model here. In this case, my disk model is VMware because it's virtual USB drive. Actually, consider this as your virtual USB drive. SDA here, as you can see, this is the SDA and this is the STB. So this consider this as this flash drive to be forensically acquired, and SDA is your primary hard disk. Here, as you can see, we have with 3 partitions. So in order to maintain the evidence integrity, so let's look inside our actual, for example, let's create just a documents here, HATSCARE secrets here, for example, here, or for example, let's create another file, company documents, and for example, for example. So we have files in it. So let's do again fdisk command for what. Look at inside this file. Actually, let's write inside this file something here. We can write as well in our terminal here. This is the, for example, write this as well here, and write this as well. So now let's run the fdisk command. As you can see here, we have our bytes is changed here. So let's continue. Let's make an in order to provide proof that the evidence was not tampered with, a hash of the evidence should be provided before and during or after an acquisition. So let's create an hash file, evidence hash file, and let's write in this hash file, for example, what clock is that, 09, oops, okay, so there is a 09:47 AM here, and then let's run our MD5 MD5 sum here, and write here your disk STB here. For example, in my case, it is the in dev STB location here, dev STB here. Actually, we have to run it as sudo. It's calculating now. As you can see, there is our MD5 sum of our this device is here. Our clock is changed, as you can see here. So this is the MD5. Actually, let's add description. Description MD5 MD5 sum of dev STB device, and let's make 3 GB device here. So now, for example, in the previous example, the output of the MD5 sum command, MD5 sum command of the 3 GB flash drive is displayed as 11-0A4C67. They started with that. So when performing the accusation or forensics imaging of the drive using DC3DD, we should also have the extract result when hashing the created image file output to ensure that the both original evidence and the copy are exactly the same, thereby maintaining integrity of the device. So actually, we have CHA1 hash as well, which will be used for comparative purposes using the here. For example, CHA1, actually we will use sudo command, sudo CHA1 sum, actually CHA1 sum, and dev STB. So see, in this time our Kali Linux machine is calculating our CHA1 sum, and this is the CHA1 sum of our evidence here. So in what time is it? 09:48, actually 50 AM, and this is the CHA1, and this is the MD5. So description MD5 sum, or actually not MD5, CHA1 sum of dev STB divides 3 GB, and we will also add that we haven't changed this device here, no changed after MD5 sum calculating. So I know that we can identify our devices and create MD5 and CHA1 hashes in Kali Linux. So let's move on to using DC3DD. So for using this, before we get starting using DC3DD, we have to install this application here, DC3DD. Actually, sudo apt get install DC3DD. You can install DC3DD like that. Actually, it's will be more good to increase this font size a little bit. Here, as you can see, you can install your DC3DD like that. So before we get started, I need to again drive your attention to one of the features of DD here. So being able to wipe data, partitions and drives. Hence, you may find that DD is sometimes also fondly referred as data destroyer. So be sure to always first identify your devices, partitions, input and output files and parameters when using DD and DC3DD commands. So there are features of DD. For example, let me right here. Actually, let's save this. We will need these hash files, so don't delete this. I have practical examples on them. So let's open, for example, empty file here, dd here, and open this. So the features of dd. So dd is good for copying folders and files. For example, bitstream data disk acquisition. So this means this raw in raw format is good. For example, copying disk partitions. For example, we can check hard drives, check storage disk error, and forensic wiping all data on hard disk drives. So DC3DD is actually was developed by the Department of Defense Cyber Crime Center. So, and is updated whenever DD updates. So DC3DD offers the base DD with more features. For example, this is including for example, we can do DC3DD hash verification. We can write errors to file. We can split output files. We can verification of files. We can wipe and output files, and pattern wiping as well. Although we will only be looking at DD and DC3DD, there is also another tools called DCFLDD, which can be installed on Linux-based systems. So DC3DD is patch of DD and is regularly updated whenever there are updates to this DD. So DC3DD offers more features than DD, which is why we will be using it now. So actually, let's get our practical examples now. So now, as you remember, we have a hashed this some files. We calculated CHA1 and MD5 sum of these device. So let's change something here. For example, open our device, and for example, let's click on company documents here, and actually, yes, as you can see, we have company documents here. We write some unmeaningful words here. For example, let's write for example or something that not AST, let's for example KC like that, and we changed this file. So we changed and we saved this file. So let's close this and open our here we will do an some file as well here. Evidence hash file, and open our terminal. So now we will, after changing some files, so changing some files, for example, what o'clock is that? 09:57 AM, and let's do first the MD5 sum calculating. So MD5 sum dev STB with sudo command, of course, Kali. So we are now calculating MD5 sum of our dev STB device here. As you can see here, our MD5 is completely another MD5 here, another text here, because we changed our file and we can't verify our data anymore. So because it's changed, so this is why I'm telling you that every time in this course that this verification and checking this sum of your digital evidence is most important thing in digital forensics. So for example, let's do the CHA1 sum of our dev SDBay device here. This will change as well because we changed our files in it. So it doesn't matter if we calculate this file with CHA1 or CHA256, this file is changed. So in order to get this result, we have to paste the deleted content, and we have to these files have to bit by bit equivalent as the previous one, but in this case it's not. So CHA1, as you can see here, our CHA1 and MD5 is completely different now. So this for example, in next lecture we will use the dec3dd command, and I'm waiting you in next lecture.